Hey, 8th grade. In this video, we're going to take what we learned about linear programming in the last video and apply it to some business word problems in order to maximize profit. So I have a couple of examples for you. Let's take a look at number one here. So in this scenario, we're a baker, and we're going to be baking two different types of things, corn muffins and bran muffins. And so this problem describes what ingredients it takes to make a tray of corn muffins. So it tells you it takes 4 cups of milk and 3 cups of wheat flour to make one tray of corn muffins, and then for your bran muffins, 2 cups of milk and 3 cups of wheat flour. We also know that in our pantry we only have 16 cups of milk and 15 cups of wheat flour to use. The last thing it tells us is that if we're selling these muffins, we're going to make $3 profit per tray of corn muffins and $2 profit per tray of bran muffins. And so our job is to decide how many trays of each type of muffin should we make in order to maximize our profit. Okay, and a lot of times businesses have to figure this out. So if you own a restaurant and you have to make food ahead of time, okay, let's say you have to make a lot of salads ahead of time and they're only good for 24 hours. Okay, you want to figure out based on your ingredients how many salads of each type should you maximize, should you make in order to maximize your profit. And you can base that on a lot of different scenarios, how many ingredients you have, what the costs are per ingredient, how many you think you're going to sell. And so this is just going to be a very basic intro to that sort of scenario. Okay, what's going to be the best way to maximize your earnings, okay, to forecast your earnings. So in this problem, like all word problems, we're going to start out by defining our variables. So we're trying to find how many trays of each type of muffin we're going to make. Since we have two types of muffins, we're going to use two variables. So we'll let x be equal to the number of trays of corn muffins, and y can be equal to the number of trays of bran muffins. Okay, step 2 here, we're going to write a system of inequalities, and the number of inequalities you write for each of these word problems is going to vary based on how many constraints you have. So in this problem, I'm going to go through and I'm going to highlight my constraints. Okay, one constraint you're going to always have is the minimum number of things you're going to make, in this case the number of trays. And so this is a real world scenario. I'm making actual trays of muffins, and so your x, which is your number of trays of corn muffins, okay, x is not going to be a negative number in this. There's no way to make a negative number of corn muffins, so we're going to say that x is greater than or equal to 0. I may not make any trays, but I'm not going to make -1 trays. And I'm going to say the same thing for y. So for each of these scenarios, you're always going to have one inequality that involves just x and one that involves just y, and you're going to be setting a minimum value for both x and y. So we're going to say x and y are both greater than or equal to 0. Another inequality I'm going to write is one that deals with my constraints on my ingredients. Okay, so if you look down here in this third sentence here, it's telling us that our baker has only 16 cups of milk. So there's a constraint on the number of cups of milk. So I'm going to write an inequality that involves the number of cups of milk, and I'm going to get that inequality from both this constraint right here and how many cups of milk does it take to make one tray of muffins. Well, up here it tells us it takes 4 cups to make one tray of corn muffins and 2 cups to make one tray of bran muffins. So that means if we take 4 times the number of trays of corn muffins, that would be 4x, and we add 2 times the number of trays of bran muffins, that would be 2y. Whatever this number is, okay, the total number of cups of milk that we use has to be less than or equal to 16. Okay, because if we make more than 16 cups of milk, we're going to run out of milk. So this inequality that I wrote right here is a constraint on our milk ingredient. My second inequality is going to involve a constraint on my wheat flour, which is 15. I only have 15 cups of wheat flour, so I can't use more than 15. So if you go up here, you see that it takes 3 cups to make a tray of corn muffins and also 3 cups to make a tray of bran muffins. So this inequality is going to be 3x plus 3y is less than or equal to 15. Okay, once we have our constraints written, and again it's going to vary for problems, sometimes there may be more than just these 4 constraints here, we're going to go to our graphing calculator and we're going to graph all of these inequalities. So if you go to your graphing calculator, delete any graphs you have on there already. Let's start out with x is greater than or equal to 0 and y is greater than or equal to 0. If you remember how to graph an inequality, or if you forget how to graph an inequality, if you bring up your function menu, okay, you have to be in function format. If you hit backspace on your equal sign, that's going to bring up these inequality signs, and then you can just type in the one you need. So we need y is greater than or equal to 0. We can graph that right there, okay? Now, your graphing calculators will not graph x is greater than or equal to 0 because you have to be in slope-intercept form to do an inequality. So all I'm going to do is I'm going to go to my menu bar. I'm going to go to menu, 3, 2, 1, 2 to put this in x equals form. I'm just going to graph the equation x equals 0. The only thing it's not going to put on here is the shading. Okay, so it's going to put the line here in blue, just not the shading that we want. Okay, and then I'm going to go through and I'm going to graph my two other inequalities. These are both in standard form, so you have two options when you're graphing these. You can graph them in standard form in your calculator, but your calculator won't do inequalities and won't do any shading in standard form. Or you can change them to slope-intercept form on your paper and then type that into your calculator as an inequality. So that's what I'm going to do here really quick. I'm going to change both of these to slope-intercept form. And that's going to give me y equals negative 2x plus 8. So I'm going to type that one into my calculator. Go back to function form. And I want y is less than or equal to negative 2x plus 8. Okay, and then I'm going to change my other inequality to slope-intercept form. If I change this one to slope-intercept form, I get y is less than or equal to negative x plus 5. Okay, and so here are my four lines. Again, I have the x-axis and the y-axis shaded to the right and above, and then I have these two lines right here, and these are both shaded below, so my feasible region here is going to be this little trapezoid region right here. Okay, so now what I'm going to do is I'm going to transfer what I had in this graph to my coordinate plane on my notes paper, just so I can see this graph on my notes when I go back to refer to that. So let me just quickly sketch that graph here to this coordinate plane. So on that graph we have vertices at 0, 0, 0, 5, 4, 0, and 3, 2. Okay, so this right here is what my feasible region looks like. Okay, and again, you can clearly see that from the graph. Here's 0, 0, here's 0, 5, here's 3, 2, here's 4, 0. And now what I'm going to do is I'm going to write these vertices down here in step 4. So my vertices again are 0, 0, 0, 5, 4, 0, and 3, 2. Okay, now what I'm going to do in step 5 is I'm going to write my objective function. Okay, so this is something in the last set of notes that I gave to you, and these word problems here, this is something that you're going to need to come up with on your own, but it's really easy. You just have to find the part in the word problem that gives you the profit. Okay, so your objective function is always based on profit. Sometimes I'll call that your profit function for these problems. And so the only things we haven't used yet, if you look back up here in the word problem, are the 3 and the 2. The $3 profit per tray of corn muffins and the $2 per tray of bran muffins. This is how you're going to write your objective function. So you know that your profit, f of x comma y, is going to be equal to $3 times the number of corn muffins, so 3x, plus $2 times the number of trays of bran muffins, 2y. So that's always where you get your objective function, is from your profit. Now I'm going to go down to this table right here, and I am just going to substitute in my 4 different vertices for this objective function. Okay, so in this column right here, my inputs are going to be ordered pairs, x comma y, and so my four vertices are 0, 0, 0, 5, 4, 0, and 3, 2. Okay, to find the actual outputs, we're going to plug these into, again, our profit function, 3x plus 2y. So for 3, 0, that would just be 3 times 0 plus 2 times 0. For 0, 5, 3 times 0 plus 2 times 5. 4, 0, 3 times 4 plus 2 times 0. And for 3, 2, it'd be 3 times 3 plus 2 times 2. Okay, so our outputs for this one are going to be f of xy. So this first one will get 0. Our second output would be 10, 12, and then 13. And so our job was to find the maximum profit based on these four outputs right here. I can see that my maximum is 13. And so this would be my maximum profit. So we can say that this ordered pair right here is going to be the input that maximizes our profit function, ordered pair 3, 2. And so that means since x was 3, or since x was the number of trays of corn muffins, we need 3 trays of corn muffins. And 2 trays of bran muffins. That will be the ordered pair that maximizes our profit for this situation. Okay, I have one more I want to show you, so let's go to example 2. In this one, we're going to be taking steel and converting it into girders and rods. And so it says that the Bethlehem steel mill can produce at most 100 units of steel each day. At least 20 girders and at least 60 rods are required daily by regular customers. The profit on a girder is $8 each, and the profit on a rod is $6. And so we want to know how many girders and how many rods should we make in order to maximize our profit. So for the last problem, the items we were making were corn muffins and bran muffins. In this problem, it's going to be girders and rods. So I'll let x equal the number of girders, and y will equal the number of rods. Okay, your system of inequalities, again, you're going to write inequalities that list your constraints. We have 3 constraints in this problem. Okay, so in the last problem I said that x and y both had to be greater than or equal to 0, okay, because you can't make a negative number of corn muffins or bran muffins. And this problem right here, you're actually given your minimum values, okay? It says at least 20 girders and at least 60 rods are required, okay? So instead of x and y being greater than or equal to 0, we're going to say that x is greater than or equal to 20 and y is greater than or equal to 60. So they're giving us the minimums here actually in the problem. If they hadn't said that, then we would say x is greater than or equal to 0, y is greater than or equal to 0. My other constraint is this. It says the mill can produce at most 100 units of steel each day. Okay, now it doesn't say 100 rods or 100 girders. It says units of steel. And so when it uses this phrase, units of steel, that's going to assume a combination of both girders and rods. So we're going to say that the number of girders plus the number of rods has to be less than or equal to 100. Okay, less than or equal to 100, but the numbers each, there has to be at least 20 girders and at least 40 or 60 rods. So this is going to be the constraints for our system here. So now we're going to go to our graphing calculator. We'll go ahead and delete those last sets of graphs. I'll graph these functions here, and I'm going to show you how to do this just by using equations, not inequalities, for this problem right here, just because I think if you put too much shading on your calculator, sometimes it can look messy. So my first function I'll graph is y is greater than or equal to 60. I'm just going to do the line y equals 60. I'm going to have to zoom out a bit so I can see that. Okay. Second equation I'm going to do is x is greater than or equal to 20. So I'll go to my x equals form. I'll just do x equals 20. Okay, so I can see there's my 2 lines. Imagine, again, they're shading above and to the right of this. And then the last line I'm going to do is x plus y is less than or equal to 100. I'll go ahead and I'll do a standard form for this one, and I'll do just x plus y equals 100. There we go. And so my feasible region, because we're shading below this line right here, okay, the line that's in red right here, my feasible region is going to be this little triangle portion right here, okay? And so what I'm going to do is I'm going to find the vertices of this feasible region right here, okay? Now, there's a way to find each of these vertices on your calculator if you remember how to use that intersection feature. If you go to menu 6.4, okay, that's going to allow you to find intersection points on your calculator. Since we have more than 2 lines on this, it's going to ask us first to pick the graph that we want to find the intersection points of. So the first intersection point I'm going to find is this bottom one right here. So I'm going to pick this first blue line and then this second blue line to find the intersection point of this, and then it's going to ask me first corner. All that means is I'm going to draw a box around this intersection point. So I'm going to click and then drag a box, and that tells me that my first vertice down here is at 2060. Okay, so first vertice I have is 2060. I'm going to do the same thing for this top vertice up here to identify that one. So menu 6.4, I'm going to pick my vertical blue line and then my red line here. Okay, since those both intersect to get this vertice up here, I'm going to go ahead and drag my box, and that tells me it's at 2080. So I have another vertice at 2080. And then the last thing I'm going to find is this third vertice down here. So again, menu 6.4. This is my horizontal blue line and my red line intersecting. And this one, it's going to ask me lower bound, just like it did for regular intersection points. I'll just click and drag my window there, and that one I get 4060. So that's a way that you can find the intersection points on your calculator. And if you'd again like to transfer that graph from your calculator to this graph right here, you can do that. Okay, and this is what that graph would look like. So now I'm going to go down, I'm going to write my profit function now. So again, you're going to look back up at your word problem and determine what your profits are. So it says we make $8 per girder and $6 per rod. And so my profit function is going to be f of x comma y equals 8x plus 6y. And now I'm going to go down to my table and I'm going to list my vertices once more. And then I'm going to plug each of those vertices into my profit function. If you'd like to try this on your own, click pause in the video and then click play to check your answers over here. Okay, so this is what your table should look like, plugging each of these vertices into your profit function. For 2060, you get an output of 520. For 2080, you get an output of 640. And for 4060, you get an output of 680. And so my maximum for this one is going to be my 680. So that tells me, based on my constraints, that I need to make 40 girders and 60 rods. Okay, so I know there's a lot of pieces that go to each of these problems. Feel free to go back and rewatch anything that you need to. Once you do that, there should be homework over this section posted, and then your study guides for your test are also posted on Google Drive. So feel free to start those. And until I see you again, have a nice day. You're all wonderful people. Take care.